student. Today we are going to discuss about Laplace transform. As we know that this one is a part of an integral transform. There are several integral transform: Laplace transform, Fourier transform, Henkel transform, Jet transform. So what will happen in an integral transform? In an integral transform we convert the one function to another function in all integral transform. So in a Laplace transform also we transform one function to another function. So now one question fundamentally initially arises: what is the need of a study of a integral transform, or particularly Laplace transform? So as we say that in integral transform we transform one function to another function. So if we transform one function to another function, so there is a chance if we transform the function, the transformed function become easy for the analysis. For example, if we take a Laplace transform of a differential equation with initial values, then this one converted into a algebraic equation. Then to find out a solution of algebraic equation much easier in comparison of a solution of a differential equation. So once we take a Laplace transform, then this one converted into a algebraic equation, then we solve the algebraic equation, then again we perform the inverse Laplace transform in order to find out the original solution of a differential equation. So this one is a one application of a Laplace transform. There are many more application of a Laplace transform in a science and engineering. So roughly means in a layman language we say that in a Laplace transform we are going to transform one function to another function, and the transformed function become easier for the analysis purposes. So now let us define the Laplace transform. So what is the Laplace transform? How we define a Laplace transform? As we say that in a Laplace transform we transform one function to another function. So here let ft be any function, ft be any function, any function defined for all real t greater than 0. Then Laplace transform, this one is a notation of a Laplace transform. We write a L of a ft, L of a ft equal 0 to infinite e to power minus st ft dt, and we denote this, the value of this integral, this one is a function of s. So we denote this one by the capital Fs. So we transform the function ft into a capital Fs, means one another function. We transform from ft to Fs. So if we closely observe the right hand side of a Laplace transform, this is the what? This is a improper integral. What is an improper integral? One of the definition of an improper integral, if any one limit, lower or upper limit with the infinite, then integration is a improper integral. So here upper limit is infinite, so this one is a improper integral. So improper integral, this one is an improper integral. So if improper integral, when the Laplace transform exists, if improper integral converges for any value of a s, otherwise Laplace transform does not exist. So Laplace transform of any function is nothing else improper integral. What is the improper integral? 0 to infinity e to power minus st ft dt. This Laplace transform of a ft will exist only if improper integral converges for any value of a s. So, here we write as a remark, Laplace transform of ft will exist if improper integral converges for any value of a s, for any value of s. Otherwise, Laplace transform of a ft will not exist. So, this one is a proper definition of a Laplace transform. Once again, if ft be any function defined for all real t is greater than 0, then Laplace transform of ft equals 0 to infinity e to power minus st ft dt, and this one converted to one another function and the variable of the function is s. So, here we denote Laplace transform of a small ft equal to the capital Fs. So, Laplace transform of a ft only exists if this improper integral converges for any value of a s. So, once here we discuss the improper integral, Laplace transform of a ft will exist if improper integral converges for any value of a s. So, this can be also written, this improper integral can be also written as like this one, means Laplace transform of a ft equal 0 to infinite e to power minus st ft dt. This can be also written as limit v tends to 0, v tends to not 0, v tends to infinite, 0 to v e to power minus st ft dt. So, when this Laplace transform or when this improper integral converges, so if there are two property when this improper integral will converge. First one is if integral 0 to v e to power minus st ft dt will exist for all values of a v greater than 0. Exist for all v greater than 0. And second one, limit v tends to infinite will also exist. Limit v tends to infinite of this integral will also exist, then this improper integral will converge, improper integral will converge at limiting point as v tends to infinite. Otherwise improper integral will diverge. So, for the existence of a Laplace transform, it must be necessary this improper integral will converge. This improper integral will be converges if integrate 0 to b, if we write this improper integral in this form, then if this integral exists for all values of a v greater than 0 and limiting value of a v tends to infinite will also exist, then this improper integral will converge, and converge at which point? The limiting value of this integral is nothing else the convergence point. Otherwise, this improper integral will diverge. Now, we try to find out Laplace transform of some elementary function. What are our teaching, our lecture plan? Our lecture plan is first we find a Laplace transform of some elementary function. Then, how we find the Laplace transform of a sum of a elementary function, multiplication of a elementary function, or division of a elementary function, or derivative of a elementary function, or integration of a elementary function. So, first we find the Laplace transform of a elementary function, then sum of a elementary function by using the linearity property, then we discuss about change of scale properties, shifting property 1, shifting property 2, then multiplication property multiplied by t, division by t, derivative of a t, derivative of any function, and integration of any function, how we find the Laplace transform of integration of any function. Then we discuss about inverse of a Laplace transform.